Solar flares. A powerful concentrated outburst of electromagnetic radiation in the Sun's atmosphere is known as a solar flare. In areas where the Sun is active, flares frequently coexist with solar particle events, coronal mass ejections, and other solar phenomena, albeit not always. The 11-year solar cycle affects how frequently solar flares occur. The acceleration of charged particles in the surrounding plasma caused by magnetic energy stored in the Sun's atmosphere is assumed to be the cause of solar flares. This causes electromagnetic radiation spanning the electromagnetic spectrum to be emitted. The daytime side of Earth's upper atmosphere, specifically the ionosphere, absorbs high-energy electromagnetic radiation from solar flares, preventing it from reaching the Earth. The ionization of the ionosphere may momentarily increase due to this absorption, potentially interfering with shortwave radio communication. A current field of study is the forecasting of solar flares. All layers of the solar atmosphere are impacted by solar flares: photosphere, chromosphere, and corona. Electrons, protons, and heavier ions are accelerated to speeds that are very close to the speed of light, while the plasma medium is heated to tens of millions of kelvins. Radiation from flares spans the entire electromagnetic spectrum, from radio waves to gamma rays, and is produced at all wavelengths. The majority of the flares must be examined using specialized equipment, since the majority of the energy is dispersed over frequencies outside of the optical spectrum. Intense magnetic fields that pass through the photosphere and connect the corona to the solar interior are present in active zones, which are frequently found surrounding sunspots. The sudden, within minutes to tens of minutes, release of magnetic energy from the corona fuels flares. Although it is yet unclear how flares and coronal mass ejections, CMEs, are related, the same energy releases may cause CMEs. An energy release of 1020 joules or less often produces a clearly observable event, while a big event can emit up to 1025 joules. Solar flares occur in a power law spectrum of magnitudes. Flare sprays are related to solar flares. They can travel at speeds of 20 to 2000 km per second and involve material ejections that are quicker than those of eruptive prominences.